Today we are going to see a really nice question from the chapter periodic classification of elements. So it says कि fluorine gas goes to fluorine gas positive ion plus electron, and F minus to F gas, Cl gas to Cl plus, Cl minus to Cl gas. All are releasing electron. I mean, this means that this is the ionization energies, respective ionization energies of all four processes. So to solve this question, this is a multiple correct question and we have four options that goes like this. You can try on your own. Okay, here are the A and C option, here are the B and D options. So let's firstly see the option A. So for A we have F gas goes to F plus gas plus electron. This is also very important to mention that ionization energies and all the other electron affinity and else are considered only for isolated atom, I mean at gaseous state. If he would have given in the solid state or liquid state, we could have not guessed that it's proper or not, because hydration and many other things vary there. But now this is simple, this is just the ionization energy. Let me call it I1, and F minus gas to F gas plus electron, this is I2. So we are first of all, the thing that comes to mind is that, oh my god, this is fully filled this is a fully filled configuration. It has what's the configuration of fluorine? It will be the same as of neon, and it will be 2p2 2p6 its configuration. And people say that it's 2p5 last 2s2. Yeah, so people say, oh my god, it is having the fully filled electronic configuration just like neon, so it will be very tougher to remove this electron. But wait, let's see. The option says delta H1 greater than delta H2. It means I1 greater than I2, but we are saying I2 is greater than I1. Okay, now here we have to stop and we have to analyze the things more further, because we know that F minus is the smallest ion in smallest ionic radii in the whole periodic table. So it may have different properties for and different values of ionization energy and electron affinity also. So we should check. So what we will do is, we can see that F minus is a very stable ion, and whereas F plus is very unstable, because fluorine is highly electronegative, very small atom, and on very small atom both minus and plus are unstable. Yeah, so this is kind of stable. Okay, and this is also stable. So F goes to F plus, highly electronegative atom is having a positive charge, but this is not preferred actually, because fluorine is an what? It is an halogen. First, halogens are very reactive. Why? Because they are non-metals and at the last of the periodic table. So F plus, and here F is forming the same compound from which we formed the F plus. So if we see that we are forming a very unstable product, and yeah, this thing is stable than this. I am saying this thing is stable than this. That's why when we form F minus, delta H comes out to be negative. This means that the stability of the product form is very high. It comes to be minus 328 kilojoule per mole. So I2 would be plus 328 kilojoule per mole. it means that we are going from stable to unstable, stable to unstable. But the most important thing is to note here is this is the normal state of fluorine. This has +1 oxidation state, and in the whole periodic table, fluorine never, in the whole chemistry, we have not seen any compound of fluorine with plus oxidation state. Why is that? Because fluorine is the most electronegative atom of the whole periodic table. So it's sure that this would have taken a lot of amount of energy. So we know that both are positive, because we have to supply some energy to remove an electron from a stable system. So I1 would be greater than I2. Okay, now let's go for this option. No, okay, so they are, let's go for B only. H4 and H2. What's H4? This one, Cl minus to Cl and F minus to F. Yeah, this seems to be pretty easy, because we know Cl to Cl minus plus electron, this energy comes out to be minus 350 kilojoule per mole. We can directly compare these energies, because the reverse is given in the question. The reverse of these reactions, the reverse of electron addition is given, electron removal is given in the questions. So we could say, so firstly we will say that this option is correct, and secondly the mode they have given us the mode. H4 ka mode is greater than H2. Yeah, true. We will see that directly by this only, because if we go by in ions, basically in most of the questions that we do about ionization energy, we either study first ionization energy, second ionization energy, third and successive ionization energy. We never study the ionization energies of negative anions, and suddenly this question appears in the exam. So this is a very good level question, not good level, actually something different, out of the box or out of the scope of our studies, because ions have different chemistry. Ions, this type of ions, especially anions, have different type of chemistry when you talk about ionization energies and stuff like that. So yeah, it should be taught pretty more in the schools, coachings. So now let's compare these others. I think these others can be directly compared by this, and we will it says delta H1 greater than delta H3, delta H4 greater than, so this seems to be correct. But let me see first option D, delta H1 greater than delta H2 and delta H3 greater than, no, this is wrong because of this. So this is directly wrong. Now let's study the option C. So option C says delta H1 greater than delta H3. Okay, they are saying delta H3 is greater than delta H4. This is delta H3 is greater than delta H4. Okay, we will use the same thing that we use for this, and what we will try is that again chlorine to chlorine plus we are going, chlorine minus to chlorine we are going. So this energy we know 350 kilojoules per mole. So delta H4 should be that we have seen that it's greater than delta H2. Delta H3 we have to compare. So delta H3, yeah, delta H3 should be greater than delta H4 because of the same reason that chlorine plus is formed, chlorine minus is kind of stable, chlorine is kind of stable, and we are forming unstable systems with respect to the original state that we are given. So both of them are going to stable to unstable system, but what's more unstable? This is more unstable, so it would have required more energy than this one. So yeah, this is good, but we also have to see delta S and delta S2 to compare them, because we can see that if we compare both of them, then we know that fluorine plus small atom having having a plus ion, chlorine a bigger atom having a plus ion is more stable, so it would have required lesser energy than this. So this is good, but we have to see this, that might be, but no, we don't need to see this, because we know that delta S3 is less than delta H1 and greater than delta S2, and we know that delta H4 is already greater than delta S2. We have seen this, so this is also true. So our all three options A, B, C are true, while D is false. Very nice question, probably can appear in JEE Mains. Advanced it's tougher because I don't think it's so much conceptual basics.